All right, we are live. Gonna wait just a little bit longer for anybody coming on. Let's turn on some music, I think. Let's get some music going. Well, welcome. Yeah, trying to make sure that we're live. All right, cool. So welcome everyone to the Solana Changelog. Let's turn this music down just a little bit. All right. So welcome everyone. Welcome, Tim. Good to see you. So we're going to talk about some things this week. This is for those that are not familiar with the Solana changelog. This is a thing that I try to keep up every week, to where we talk about what are the changes happening on Solana. And there are a lot of things to talk about this week. So if you haven't noticed, there is a new proposal out for under the Solana improvement documents on larger transaction sizes. So let's go pull that up and we can go talk about it and review it and talk about like how does this change how people build on Solana and potentially what you can do in the future on it. It's a very big change and I'm super excited. So let me make sure I share my screen and we can get going. There we go. All right, so let's make it bigger. All right. So SIMD 296, increased transaction size limit. So for those that do not know today, the transaction size limit on Solana is capped by 1232 bytes or 1280 bytes on the network layer. This was a conscious decision by early maintainers or core engineers of the Solana network to make sure that every transaction could fit within an MTU packet. This is because early on, transaction ingestion process, the sending transactions across the network was done over UDP. If you are familiar or been around for a while on Solana, you know that everything changed in, I think, 2023 to Quick. And within Quick, they are allowed to do more. Now, note there are some things that we'll cover in a moment that are some on the downside of, or the trade-offs for doing this, but there is a proposal today to increase transaction size limitation from 1232 bytes to 4096 bytes, so about 4 kilobytes. And the reason being, there's a number of reasons. This should unlock a lot of major use cases on Solana that people would like to do today. Things like bigger and larger cryptography scheme proofs sizes or signature scheme proofs. Things like, I think they're the one that we use for conventional balances, and we can go check the actual commit. Let's just view the file so I can talk to it as we view it. Things like the ZK proofs that are used within confidential balances, or the untruncated winternits one-time signatures. These are things like if you saw Dean Little put out winternits for quantum resistance on Solana. He did that a while ago. We have the nested multi-sig that corporations like squads use. You can do a lot more larger things such as BLS within just the Solana runtime. You don't have to worry about like recompiles getting built. So this can unlock. These are just some of the use cases. There's a ton of use cases, and making smart wallets better, making it so they don't have to work with address lookup tables. So there's a ton of additional use cases of different things that you could potentially do on Solana, all just unlocked by having larger transaction sizes. Now note, for anybody that is watching, this is just a proposal. It's still going through proposal change. I just proposed it, 2 days ago on Wednesday? And if you look, there's a ton of comments. Let's go look at the comments. So yeah, there's just an absolute ton of comments on the different parts of the proposal that we can kind of get into here. And if you do have any questions, feel free to ask them in the chat. If you don't know how the chat works on Twitter or X, you can just click into the live stream and then you can chat with me. More than happy to talk about it. In fact, I love chatting with people on this. Cool. So let's go through this. So there's a number of things to kind of note. And I'm going to open this in a new tab so we can kind of look at it. All right. So we know the motivation. Unlock more use cases on Solana. Make transaction size bigger to unlock more use cases on Solana. But what does this actually change? So I mentioned Quick earlier. The Quick RFC 9000, which is hilarious. I think the number is hilarious. But the specification does not have an explicit maximum stream size, allowing for larger transactions to be sent. There's actually a common format of, I think they're called jumbo frames that are sent, which are around 9,000-ish bytes. Now, we don't update to that in this proposal, but that is a future potential of a use case. Now, note, this whole larger transaction size comes with a pretty big change on Solana. Specifically, the change would be a new transaction format. So if you're familiar with transaction V1, and let's just pull up this right here so we can start going through it. If you're familiar with transaction formats on Solana, today we have roughly two formats. We have the wonderfully named format Legacy, which is capped by 1232 bytes. And that's basically it. There's no like new features. It's the old format of transaction format. That's still probably what most transactions are using today on Solana. Most transactions are probably still using Legacy. Now, I can go look this up. That was speculation what I just said. But I'm willing to bet that the majority of people are just still using Legacy today. All right, the next one we have is V0. This is the first official versioned transaction to allow us to have major breaking changes onto transactions without breaking everybody else building on Solana. This came up with, it once still capped by 1232 bytes, but it gave new developers the ability to use address lookup tables. Address lookup tables can hold up to 255, I believe it's 255 addresses in it. However, you can still only load, and this is still case today, 64 accounts at once. So even though you can have 255 addresses, you can only load 64 accounts at once. So if you do the math there, let's just go bring up a calculator, right? If you do the math there, 64 times 32 is 2048 bytes. So this kind of gave the ability to do roughly about 2 kilobytes more within your transaction. That was V0, just with address lookup tables. Now we have the new format proposed of V1, which we can go into exactly what that looks like pretty soon. But so we have V1, and the V1 proposed transaction size is 4096 bytes. There's some things that are added to it or removed to it. There's no address lookup table support. And this is actually really important for those that are watching right now and those that are interested in learning more. There's a discussion within the SIMD right now of no nonce account support. That's a big deal. We can get into that in a little bit. But ultimately, because the address lookup tables can only load 64 accounts at once, this will actually have a much larger size that you can potentially do with V1 than you could have done with V0. So you don't need address lookup tables. Address lookup tables are actually pretty bad for the cluster. And removing them is a kind of an IBRL type of move, increase bandwidth, reduce latency. So we're looking at moving to this V1 format. Now, that doesn't mean that the V0 format or the legacy format will get removed. So if you're still using code that uses legacy transactions or V0 format. Those will still exist and those will still be enabled. They're not, so if this proposal gets accepted and implemented, it doesn't necessarily mean that V1 is going to turn on and then V0 and legacy are just no longer going to exist. That is not the case. V1 will turn on and will live in kind of harmony with V0 and legacy. The idea, though, is that V1 will have enough reason for people to move over V0 and legacy that people will start migrating from V0 to V1 or from legacy to V1 because you can do so much more in a transaction. In fact, from legacy to V1, there's almost no reason why you shouldn't migrate. It's going to be faster. It's going to be easier to land transactions and a whole bunch more. Now, let's think about a little bit more for V1. There's also the case where V1 will kind of enshrine the already enshrined compute budget program in the header. So what we have is V1 transactions will allow you to request different budgets directly in the header, not in an instruction. So normally in an instruction, you might have the compute budget program ID. That's 32 bytes gone immediately. You won't need to do that for this request budget header. You will actually just be able to request your budget or your different compute units or add your priority fee directly in the header for almost 0 bytes. So you even have more space in your V1. There's also the case that there's a consideration of removing default compute budget. So what does this mean? Today, transactions have roughly about 200K CU default, right? Now, this is not all transactions. There's some special cases, but we can talk about those if people have questions about that. But today, most transactions have a 200K CU default per instruction that they use. Now, with V0 or V1, there is consideration to remove that default completely. Just have it as 0. Now, this is a major breaking change on the transaction version. So your current transaction versions will not break. It'll only be if you're using V1 will it break. And once again, for people that are joining right now, if you are interested in commenting or joining the discussion, you're welcome to, and you're on X or Twitter, you click into the live stream and then you can talk about it, basically. I'd love to talk a little bit more about what kind of things people are interested in learning more about V1 transactions. So yeah, the transaction CU default might go to 0. This is still in the proposal, still being discussed, but it might be. And so that means that you have to include your compute budget every single time. So again, to recap, V1, it's interesting that there we go. To recap, V1 will have a max size, or is a proposed max size of 40 to 96 bytes. It will have no address lookup table support. It's currently in discussion of whether or not it should have nonce account support at all. Nonce accounts are also bad for the cluster, and there's actually better ways of doing that, and we might see another SIMD soon to talk about how to do better nonce accounts and also a path forward for developers to migrate to. You will have compute budget request in the header, so you request budgets with a lot less bytes used, and this opens up an easier way for you to request different types of budgets in the future. So today we have account loaded budget. We also have the ability to request more compute for a single transaction, and we also get the ability to pay a certain priority fee per compute unit in the budget or in the header. This all can change. or this will all change to just be directly in the header versus an instruction. There's a discussion right now, a proposed discussion to remove the default compute budget and break it down from 200K CU default to 0 CU. This will be a breaking change. Of course, we're in a different transaction version, so it's okay. And this is mainly going to, let's just showcase where it's coming from. Solana improvement documents. I think it's 172, if I remember correctly. 172 removes the default CU budget. Let's see. Yep. It reduces the default CU per instruction to 0. This is from SIMD 172. The only problem with SIMD 172 is it's a little bit too much breaking of a change, right? We can't guarantee that people will use it, and people that are not using CUs requested on, not using CU requested on transactions, it covers about 11% of all transactions on the network. So we can't necessarily make this one happen. However, we can make it happen in V1. And so if there's enough reason for people to move from legacy in V0 to V1, we could potentially remove it completely and solve SIMD 172 as well as all these other problems. All right. So that's a potential discussion right there. So this is a huge change, right? V1 transactions are an immense change. You can do a whole lot more with this, but there are even more. And if you see the title of this live stream, it's larger transaction sizes and other DX improvements this year. There are more things coming down the line. So this is one thing. So let's go table this real quick. And if anybody has any questions, feel free to put it in the chat. If you don't know how to work Twitter or X chat, you got to click into the live stream and then you just type away. Let's see. So transaction size increase is the first one to 4096 bytes. This is a proposal. What are the other DX improvements that are happening on the cluster that can greatly increase the developer experience for developers building on Solana? So first, transaction size increase to 4096 bytes. Ideally, that happens this year. It might spill over in the next year. We'll see. But we'll get there soon. So that's the first one. The other one is CU depth limitation. So currently that is 4, right? So what that means is if you have a program, let's just build some things real quick. Program. So if a program calls a program, calls a program, calls a program. So we'll just build this out real quick. If this happens to where there's a nested depth of 4 today, if you do this, this is fine. You can do this today and you're all good to go. However, let's say you want to, let's say people do this today, right? Where they have a program that calls a program that calls a program that calls a program. What if you want a smart wallet, right? So this is a smart wallet, which is actually a program. If you wanted the smart wallet to then go from there to there, you wouldn't be able to do this last one because you have a nested CPI depth limitation of 4. So it's 1, 2, 3, 4. As soon as you get to the 4, you can't do any more. This year, or there's a proposal to go from 4 to 8 of the CU or CPI depth limitation. This is not CU, it's CPI depth limitation. This allows you to go deeper into things and allow you to do more. And see, we got some questions in chat. Taking the chance to lower and eliminate default CU is a great idea when congestion. Thank you, Ronnie. I agree. And then no questions, just following along. Enjoy it. I appreciate you being here, Louis. So this is the CPI depth limitation. This is today, if you were to add smart wallets, and today people are using for CPI depth limits, you would then not be able to do some transactions on the network. They would not complete, right? You would fail on the last CPI. This is, I believe this is one of the SIMDs. Let's look at which one it is. So yeah, raise 268. 268 is raising the CPI 268 is rating the CPI nesting limit from 4 to 8. It's a pretty great change. It is a proposed change still. It's not accepted. I would like to see this accepted pretty soon. I'm going to do some pushing on this to see if I can get the right buttons pressed to get it done. But if you can go from 4 to 8, suddenly smart wallets can do more. Both the transaction size increase as well as CPI depth limitation increase from 4 to 8 are huge for smart wallets and account abstraction. Account abstraction already exists on Solana, like you can do it, but you can do so much more with it if you have these two features. All right, cool. So what else? What else is going on? I'm just going to throw this away. We can come back to that later. All right. So what else is going on? We'll make a nice little thing right here. DX improvements. Oops. All right. So first is the transaction size increase from from current to 4096 bytes. Second one is CPI depth limitation from 4 to 8. The third one is dynamic stack frames. So today what we have is you have 4096 bytes, I believe, on the stack frame. So if you ever built on Solana and you run into a stack size limitation, say you blew out the stack and it's like, good luck, have fun, as a Solana developer. This is because you're limited. You have a limited stack size and that's all you get. But what if you could have more? So dynamic stack frames, it allows you to request more. This is actually already a SIMD. Let's see if I can look it up real quick. Dynamic stack frames 166. All right, so dynamic stack frames allows you to potentially ask for more. This is proposed by the runtime team. Let's see, it was run. So proposed by the runtime team. It will still reserve the original 4096 bytes in case you want to, but it's suboptimal. Like you could do more potentially. So allow you to do more, you can optimize more on the cluster as well, but not have you only set to 4096 bytes. And we have a question. Hello, Fabio. Good to see you again. Is getting rid of the 32 bytes for calling a compute budget program part of the SIMD or separate? It is part of the SIMD for 296. So in 296, there is just to answer this question as an aside, if you look at let's go to the actual discussion. So we're going to get into the weeds of 296. This is where it's a little bit more confusing on first glance, but it's helped you understand like how does it work. So every transaction has a header. So let's start with that real quick. Let's go down here real quick. So we have a transaction. This is going to have like this is going to be like app dev contents or whatever. Every transaction has a header though. So we're going to add a little header here, and this is going to be the transaction header, right? And then this makes up a transaction. Cool. So this all together is a transaction. It has a transaction header. So if you look at the actual Solana improvement document for 296, it has the proposed format for V1. And in the proposed format, there's a bunch of information about that, like your version byte to be different from legacy V0. You have some information about like required signatures and payload length. Payload length is really nice so that people can, on the IBRL side, on the core dev side, can know exactly how to figure this out really quickly or to serialize it very quickly. But specifically what you're asking for is resource request mask, which is U16, which basically says, hey, given this specific mask, this bit mask, which resource requests are going to be enabled. And then in here, in the resource requests, you would map the bitmap mask to your resource request, which is a array of U64s, to understand what are people requesting. So what this means is, let's say we have this is just for fun. We have 0, 1 or something, and that 1 is for compute budget request. And then in our array of U64s, so we have some U64, and then we have, I don't know, 400K CU. This would map in the header that 1 to that, saying like, okay, this 1 is going to request 400K CU. Go to, that's what I'm going to set it. So this is a part of the proposal to get rid of the 32 bytes for calling compute budget program as part of the SIMD. Cool. So that is all part of this specific header. This is the proposed header. I can't guarantee that this header is going to look the same if you're reviewing this in the future. In fact, this is like the most discussed part of the whole SIMD. Most people are like, cool, larger transaction sizes. And they look at the transaction header and like, this could be better. But yeah, that's how it's basically set up. And if you look at some like additional improvements on the header, is that we have all of the static sized parts of the header up front, and then all of the dynamically sized part of the header at the end. So this allows you to have a little bit faster on deserialization side of things. But yeah, so that's hopefully answers your question, Fabio. So it's a good question though, is how do we do compute budget in the future? All right, so going back to the DX improvements, dynamic stack frames we have covered. So all of these, these last two are all a prerequisite, or they have a prerequisite of direct mapping. And so direct mapping, you might ask, what the heck is direct mapping? It's in layman's terms, it's like, so an address can directly map to the information on the blockchain. A little bit more involved with that. To be perfectly honest, I'd have to pull up, let's see if I can pull it up actually real quick. The document that I wrote up a few months ago to help me remember what direct mapping is. Let's see if I can pull it up. All right. I'll just pull this over here so that people understand it. This is part of one of the SIMDs. I forget which one it is, but this is direct mapping. There we go. Whoops. All right. So we have direct mapping. What is direct mapping? So I could read this for you, but basically when we load accounts, in a buffer there is like a read buffer and an extra write. It's very consuming. The more reads and writes, you have issues. With direct mapping, you don't have to write to the buffer anymore. It just receives pointers and interacts with them directly. It's a huge, too long didn't read, huge performance increase that allows you to increase some of the other transaction caps that I've been talking to. There's some breaking changes, but I've been mostly fixing that behind the scenes. It's nothing to be people to be worried about. The people that know about the breaking change or have the breaking changes know about it at this point, because I've done a lot of analysis on who does it. But we're good to go. So we have this huge performance increase, which enables these other problems to be solved, like CPI depth limitation from 4 to 8 or dynamic stack frames. So this is a prerequisite for these two right here. So before we get CPI depth limitation increase or dynamic stack frames with increased stack frame size, direct mapping has to be active. It's currently staged to be active in 2.3, which is going to come out in September-ish timeframe. So it's a prereq for CPI depth limitation as well as dynamic stack frames. Transaction size increase is probably going to be later this year because it's a big change, but it'll be good enough. But yeah, so these are some of the different developer experience improvements that you can expect both this year and beyond. Maybe transaction size increase happens a little bit later. I would hope that it happens this year. I'm really trying to push for it, but proposals got to be accepted. We got to decide on a solution. We have to test it. So in the name of testing, for those I know in case Tim is here, I told him just probably about 30 minutes before I started this stream, I wasn't going to tell anybody, but we are going to have some kind of public testing for this. I want people to try out a transaction size increase of 4096 bytes and showcase this is what I can do with this large of a transaction size, and show the better UX, the better developer experience, etc. Of I can do more things with transactions. But we'll see when that happens. I'll do a very public announcement when we have it ready. We're basically going to make the changes. Now, note these changes will be done in this test cluster and on the legacy transaction type. So you won't actually have to make any changes on your code to test it. But it'll be fun. I hope people can enjoy it as much as I will once it goes live. But yeah, so those are kind of the things I'm looking forward to later this year for DX improvements. There's a whole bunch more. If you just go through, especially like recently, the PRs, like there's a bunch of relaxed constraints, relax limit overage, or is it coverage or overage? Okay. There's a bunch of very recent changes. What I would suggest is just reading through, especially the ones in the past like month or so. Lots of huge changes. But yeah, if anybody has any questions, feel free to put in the chat. But I think I will end this otherwise. But yeah, welcome. Thank you all for joining me today on the Solana Changelog. If you do have questions, feel free to reach out at any point in time. I'm happy to help out. You're welcome to tag me on Twitter, be like, hey, what the heck is this new transaction size thing? Or CPI depth limitation, what can I do with that? I'm happy to answer any questions. But yeah, I just wanted to run this. We will try, or at least I will try to run this every week as a Solana Changelog. Might not be me, it might be someone else, but we will get done. But yeah, thank you all for joining, and I hope to see you next week. Y'all have a good one.